Graphing using the 4-column method. This is a general form of function transformations. There are 4 different variables that are moving this function. And the function, if you notice on this page, find the word function, there's a circle above it with some parent functions in it. Notice you might see a quadratic function or natural log function or exponential function, maybe absolute value, square root, and a special function called e to the power of x. And then you have your actual how the function gets moved, right? Remember back in Algebra 1, you learned how it moved up, down, that was that k value, and how it moved left and right, and that was that h value when you did quadratics. And then when you got to Algebra 2, you really started learning about this a value, this vertical compression and stretch, the reflection over the x-axis. You may have seen that in both Algebra 1 and Algebra 2. And what's kind of new may be the reflection over the y-axis, the negative that's within inside the parentheses around that function area. So something to keep in mind. And then this b variable, which is known as the horizontal compression and stretch. Now remember, these variables sometimes in different texts might be different letters. So I do challenge you to remember that variables can be different. So if you look at a different form of text, maybe they put a C instead of H or a D instead of K. Be aware of that. Things to just keep your mind open to. Okay, so today's lesson is about how do we use the parent function. Remember what I said, that's in pink, find function, those parent functions. The parent function, how can we transform that using this 4-column method by graphing? So that's what we're going to work on. So I need you to take notes. Make sure to write all this down. A, B, H, and K are very important things. We're going to talk about the plus, the minus, all that stuff. Okay, so let's get started. So some parent functions we're going to review today. We have quadratic. Remember, that's f of x is equal to x squared. You can also say y is equal to x squared. And what I want you to notice on the left-hand side is that parent function table, right? The parent function table, there's something to think about. Right, I want you to think, what's going on where it says x to the power of 2? Under that column, what's happening? Okay, good. If you need to pause and think a little longer, do so. But symmetry is occurring, right? 4 and 4, 1 and 1, 0. Notice 0 is kind of in the middle of 1 and 1, right? It's symmetrical. There's this, what I call a butterfly effect going on. These y values are pairing with one another as long as the x values are the same distance. And if you notice it, right, you're taking this input 2. That's x. And for the second column, you're plugging in 2 and you're squaring it and you get 4, right? This is known as the parent function table. This is going to be vastly important to today when I say parent function table. So keep in mind. Another function you should be familiar with is the absolute value function. F of x is equal to the absolute value of x. Parent function table, again, notice what's going on again in that y column. Yeah, that's right, symmetry, exactly. Okay, so again, parent function table, extremely important for you to know. Now I want you to think about it. What if I said for the parent function table, I wanted to say -6? What would the y value be? That's right, 6. And if I said the x value is +6, what would the y value be? That's right, 6. So that might come up later. So just think about that. I could use different numbers from the parent function table, but I'm using the parent function, which is just a basic absolute value of x. Last but not least, we have the square root function today that we're going to review. That's f of x is equal to the square root of x. Now look at the table on this one. You got -2 is undefined. -1 is undefined. But 0, the square root of 0 is 0. Because 0 times anything, 0 times itself, 0 times 0 is 0. So I got to be thinking when I see a square root function that I can't really use negatives, right? This square root, whatever under the radical, has to be equal to or greater than 0. Think about that. That's something to keep in mind of coming on later. Another thing is look at what's happening when x is 2. And you got that wonderful square root which is now a decimal, right? That's not an exact number, it's approximate. So we don't like that. So then notice I did 0, 1, 2, 4. I skipped 3. Why did I skip 3? That's right, decimal. 4. Well, what's the square root of 4? It's 2. Oh, so what's the next one I can get a square root of? Oh, that's 9, which is why I picked that number. So you want to be kind of methodical when thinking about square root functions. But if you know your square root parent function table, 0, 0, 1, 1, 4, 2, 9, 3, it'll come in handy. Okay, so let's get started with today. We're going to transform g of x. G of x is equal to negative 2 times x minus 4, quantity squared, plus 6. There's multiple ways to graph. But today we're going to learn the 4-column method. That's going to entail that you really remember your parent function. So I have a little checklist off to the side. We're going to keep all these things in order. So what is this parent function? You might say y is equal to x squared. Now what is that? That's right, quadratic. Cool, so we know it's quadratic, okay? Now, do we need to factor out the b value? So if you're like, oh, what does that mean? Okay, let me go back. B. Is there some number in front of the variable of x of our problem? Or is x just a 1x? Okay. Now you might say there's that 2, right? Maybe that 2, is that b? If you're recalling from Algebra 1 or Algebra 2, you might recall that this is actually your a value. That's your a value. And so that means that there is no b value. So we don't need this yet. Not needed for this problem, but might be for other problems. So going back to number 3, so identify what is a. Well, a is negative 2. Now, b, we said nothing, no b. And I'm going to, why would it, is x a good thing to put there? I don't think so, because look at your problem. Isn't there an x in the problem? So I don't want to say b is x. That's kind of silly. Maybe this acronym DNE, it's going to come up in calculus. It's called does not exist. B does not exist for this problem. Well, but then if b didn't exist, wouldn't that mean that okay, don't like this. Okay, I'm going to leave b as 1. I'm going to say b is 1. And when b is 1, that's a good thing, right? Because 1 times anything is anything. Okay, so now h. What's h? So when it's in the parentheses, x always lies. So that looks like negative 4, but it's positive 4. Okay, but k, we're always okay with what's on the outside, so that's going to be positive 6. So now we're going to set up our 4 columns. Here we go. We got center column. We got the work columns. We have the middle 2. These are the important ones. Remember I was saying you have to remember your parent functions. You've got to remember those parent functions. So remember this is x and this is y, but y, if you want to look over here, we claimed that y, well, didn't we say y was x squared? Y is equal to x squared. So I could put y, but I'm going to put x squared to remind myself that this is my parent function. So I'm going to start with negative 2. That gives me 4. Negative 1. That gives me 1. 0 is 1. 0 is 1. Haha, look at that. 0 is 0. 1 is 1. And 2 is 4. Okay, so we parent column. Very important. This is the parent column. Parent function table. So now what goes on the outside, right? So on the outside, on the left-hand side, we're going to do this formula that's going to say 1 over b times x plus h. And this is always true for any function. On the right-hand side, we have a times the function, whatever that y column is, plus k. Now again, I'm going to allude to some things with some highlighted. We have that this thing here is our function. That is our function. Remember, that is this beautiful function. We identified it's quadratic. So we're going to use that column there. And then, well, for x, there's an x. Don't you see the x? Yeah, we got x here. So we got x here. We're going to substitute those numbers for that x. Now notice on step 3, we have a, b, h, and k. So we can actually fill in, like, what are we going to actually multiply by? So I'm going to use this real quick. 1 over 1 is 1, so I'm not going to write that. That's silly. X plus 4. That's what I'm going to do. I'm going to take all these x values, and I'm going to add 4. Now over here on the right-hand side, we have a times f of x plus k. Well, a was negative 2. We're going to then multiply that with the x squared column, whatever's in there. So if the first one's 4, I'm going to put a 4 in. Second one is 1, I'm going to put a 1 in. And then I have plus 6. That's k. Okay, now let's do it, right? Like, let's actually see this in action. So I'm going to show a lot more steps on this example than the other ones, but that's because I want you to be able to see what I'm doing. So don't panic. You don't have to do these steps every time. Not every time, but you should get in the habit of just remembering this is the process. This is the process. So remember it says x, so that's negative 2, right? Negative 2 is x, but plus 4. That's the work I'm doing to produce my answer. Now the answer I'm going to produce is...
I didn't get that. Could you try again?
Yes, Siri. We don't need to today. Would you agree this is negative 2? I'm doing this in all 3 different colors because this is my output. This is my, like, what I actually ended up with this transformation. Okay, keep going. Negative 1 plus 4. What do you get? That's right, 3. Again, we have 0. I'm going to just write this column for a minute because this is on fun technology stuff. Plus 4. What's 0 plus 4? That's right, 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. Ooh, got a little sloppy down here. Fix it up a little. Okay, so again, what I'm showing you is that I have this y column. This x column that I'm using, this x column. And I'm inputting in the purple spot. The transformation is this plus 4. There's a plus 4. The function is moving 4 units to the right. And then I have negative 2, 3, 4, 5, 6. Hold up a second. I just caught that error. Did you see that? Negative 2. Look at that. Positive 2. Way more sense mathematically. Cool beans. Now let's move to the right-hand side. So I'm going to pre-fill this in with my blue. I'm going to give you guys a minute to actually figure it out. And we'll catch back up when you have it. You should be good. You got it. If you need, pause the video so you don't see what I'm doing to challenge yourself. Okay, now let's find our answers. Again, I'm going to continue being a little bit quiet on this one and let you think through. Okay, now let's check. Did you get what I got? Negative 2, 4, 6, 4, negative 2 is your y values of transformation. Nice work, nice work. Okay, so, yikes, that's a lot of stuff on my paper, right? What is it I'm even looking for? What is it that I'm even going to do with all this information? Sometimes this is a little overwhelming for students, especially I've noticed when graphing is not something that comes easy to you. So what I like to do with my students normally is I say, okay, with the inside stuff, I like to highlight that so that it kind of like reminds you that, hey, this stuff is just all the time. This is true anytime I say the word quadratic. Anytime I see a function that looks like this with that squared, I immediately know that goes down on this table. The A, B, H, and K is the stuff I have to mathematically conclude from this function. Then I input it into this beautiful 4-column method, and sure enough, I have the outsides, which is what I'm showing you at the end. This column is your new x's for g of x, and this is the y for g of x. So now all you have to do is graph it, because that's what you're graphing. 2, negative 2, 3, 4, 4, 6, 5, 4, 6, negative 2. Okay, last thing on this slide before I move on and we graph it, I want you to notice again that symmetry. Remember I was talking about parent function symmetry on a quadratic. Do you see the symmetry going on this function? -2, 4, 4. 6 is that vertex point, right? It's that highest point. Okay, so let's graph it. We have the outsides, so let's just put it to the plot. Okay, so I have them plotted. Next, I have to do my best to sketch that quadratic as I can. Got 1 and 2. Cool beans. So moving on. I'm going to go a lot faster next time. I just wanted to really explain what was happening. If you need a repeat, I encourage you to go back and listen again. Okay, so let's transform h of x. So step 1, you start with looking at your function. You identify the parent function. So what is this parent function? Hopefully you're all screaming. Absolute value. And that would be the function of f of x is equal to the absolute value of x. Okay. Now, do we need to factor out b? So let's think back to that formula that we had on that slide. And it was the function parenthesis negative b parenthesis x. Okay, well, okay. I see what we're talking about. You see how that says 3x, not parenthesis x? That means that I have a little more work to do before I can actually keep going on to step 3. I actually have to factor this out. So I have to think, okay, that says 3x plus 12. Well, how do I get that to say 1x? Wouldn't that mean I'd make h of x equal to the absolute value of? Can't I do something like this? X and then minus 2. So it's going to look like that. Okay, that's the basics. Something times x makes 3x. Well, what's something? Well, isn't that 3? Now 3 times what is positive 12? Isn't that positive 4? Look at that. You just factored out b. You did that. I did it. So that's that second step, that pink step. Okay. So then, going back to this A, B, H, and K stuff, would you agree? I'm going to give you, actually, pause it, see what you get. Okay, A is 1, H is negative 4, B is 3, and K is negative 2. Next, we got to set up our 4 columns. So here we go, 4 columns. Remember what goes in the very inside of these 4 columns? If you don't remember, look back at the previous example. It gives you a hint. If you're thinking parent function, absolutely correct. Parent function is what goes here. So I'm going to write my parent function, right? It's x and the absolute value of x. Okay, so let's think about this. The rule, right? We didn't give you the b rule yet, right? I only gave you when it was, well, we did do b. We talked about b, right? Wasn't it 1 over b times x plus h? Isn't that the formula here? 1 over b times x plus h. And over here it was a times f of x plus k. Based off that, wouldn't you agree that this is 1 over 3 times x minus 4, right? Based off A, B, H, K, plug it into that beautiful formula. Okay, over here, A. A is 1. Do I need to write 1 before I write f of x? I don't need to. I could, and I definitely don't need to. So I have f of x minus 2 over here. So what I'm thinking, okay, so that says 1/3 times this x column. So if I started with the normal negative 2, what's going to happen? Ding, ding, ding. I'm going to get a fraction. I want to graph a fraction. So I got to think smarter how to come up with this. What is divisible by 3? That's in the negatives. How about negative 6? Now what's the absolute value of negative 6? That's right, it's 6. Remember I talked about this earlier. I said it might come up. It was coming up. I knew it was. Okay, so we got those beautiful numbers. I did it by third, right, every 3, because again, I have that 1/3 on the outside. So again, I'm not going to write all the work. If you need the work, you write it, but I'm not going to. If I did 1/3 of negative 6, don't you agree that's negative 2? But minus 4 more, you get negative 6. 1/3 of negative 3 is negative 1. Minus 4 more is negative 5. 1/3 of 0 is, that's right, 0. Minus 4 is negative 4. 1/3 of 3 is 1. Minus 4 is negative 3. Last but not least, 6. 1/3 of 6 is 2. 2 minus 4 is negative 2. Okay, moving on to the y values that I'm going to be graphing. We have f of x minus 2. So that means 6 minus 2 is 4. 3 minus 2 is 1. 0 minus 2, negative 2. 3 minus 2, 1. 6 minus 2, 4. Perfect. Now, what does that mean? We have to go graph it. So here we go. Let's go graph. We got our beautiful function. If we scale our axes, we'll look at it by 5s because we know we're graphing negative 6 is our x, right? So we kind of want to have some cushion on the negative side of our graph. We also know that this graph is facing up because the lowest point is negative 2 for the y value. Okay, so let's get started on graphing. We have negative 6, positive 4. Negative 5, positive 1. Negative 4, negative 2. Back up, 3, 1. Notice that symmetry again. And then negative 2, positive 4. You should be getting some symmetrical aspects because, again, the parent function is symmetrical. So therefore, this should be symmetrical. If you ended up with a squiggle somewhere, then that's a clear indicator that you've calculated a number wrong. So that's where you got to go back and do some editing. But this is what we should get. Last but not least, let's move on. We have a square root function. This is the fun one. That's the parent function, right? Square root. It looks like a square root. It has a radical there. How else could they have written that so that it didn't look so square rooty? That's right, buddies. 1/2 power. They could have put parentheses around the negative 2x minus 2, and they would have raised that to the 1/2 power. Okay, so again, we mentioned this is our square root function. And we also need to write our function, right? F of x is equal to square root of x, right? That comes in handy with our parent function, 4 columns. Do we need to factor out b? Well, it kind of looks like it again. Isn't there something in front of x? So let's factor it out. We have k of x is equal to negative square root of something parenthesis x something, and then minus 2. So let's look at it. What would have to go there to make that say negative 2x? Well, don't you agree that's negative 2? Well, factor negative 2 from negative 2, and don't you agree that's positive 1? Okay, so from there, let's identify A, B, H, and K. A, negative 1. B, negative 2. H, negative 1. K, negative 2. Let's set up our 4 columns. We have, now think back to square roots, right? Remember I mentioned that square root parent function table. We didn't want to do the square roots of, wasn't it negatives, right? Because what's a negative square root of negative 4? Isn't that imaginary, plus or minus 2i maybe? So we have 0, 1, 4, 9. Now let's do 16 just to throw it in there. So now what are y values that are associated with that? Well, that'd be 0, 1, 2, 3, and 4. Now again, let's write the rules of how we actually are going to transform, right? What are the rules that we need? Aren't those rules something like 1 over b times x plus h? And then we also have a times f of x plus k. Okay, so let's do our transform, right? We got 1 over 2 that's negative times x minus 1. And on a, f of x plus h, we have a, which is negative 1, times that y value we have in that column, minus 2. Okay, so what's negative 1/2 of 0 minus 1? Ding, 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 negative 1. Now then if we do negative 1/2 of 1 minus 1, negative 3/2. Okay, well, I don't like that's a fraction. That's okay, it's a half. Do it again. Negative 1/2 of 4 minus 1. Well, again, negative 3. Cool. Let's keep going. You go. I got it. Okay, so I got negative 11/2 and negative 9. Okay, on the right-hand side, let's just go quick, right? Give you a minute. Cool beans. Hope you got negative 2, negative 3, negative 4, negative 5, and negative 6 for our values that we plugged in. So now let's go graph. Okay, so we have those fun, beautiful things. Now let's think about this. How do we set up the axis for this? Well, if you look at what you have a lot of negative x's, so you really want that left heavy side. And then you have y values that are continuing to decrease, so you really want quadrant 3, right? Quadrant 3 is what you want to graph. Okay, so let's go. Let's graph. X is negative 1, y is negative 2. Now, I'm not really good at graphing negative 3/2, but you guesstimate it, right? What is negative 3/2? Isn't that approximately negative 1.5? Oh, that's not approximately. It is negative 1.5, right? Like, that is a divisible fraction. It's not like over 9, where it's a repeating decimal. So I'm going to go to negative 1 and a little half of it, and I'm going to go to 3. You can graph it, folks. You can graph a fraction. It's all good. Negative 3 is the next one I go to, and I'm going to go down to y is negative 4. 11/2. Well, what's 10/2? That's negative 5, so it's negative 5.5, and I go down to negative 5. Last but not least, go down to x is negative 9, and go down to y is negative 6. Now notice this is it's not like super steep, but it is changing direction in terms of it's continuing left, right? It's continuing left. Doesn't that kind of look like a sideways parabola? Just the negative half of a parabola? If you turned it. Anyways, fun fact. Folks, thank you. Have a good day.